Hello, everyone. Welcome back to another episode of my teachings in chemistry. And now, in this particular video, you will be able to know how to successfully calculate questions under Hess law. Now, a lot of persons always want to exempt themselves from the teachings of Hess law to students because of its dicey nature. So in this video, be relaxed while I take my time to explain every bit of it to you. My name is Adrenaline, the Bazooka Prophet, CEO, Adrenaline Online Tutorial Platform. For any of your academic problems, do want to contact us via this contact. Now we begin. Now we should understand what Hess law actually talks about. Now, what does Hess law state? Now, Hess law of constant heat summation simply states that the total enthalpy change, take note, the total enthalpy change of a chemical reaction is what? Is constant. Underline, is constant, regardless of the route by which the chemical changes occurs, provided that the conditions of the start of the reaction is the same as the final condition. Now, according to Hess law, irrespective of the series of steps that is followed by a chemical reaction, they will all give you the same final product at the end of the day and the final heat of reaction. That is just the summary of it. So now in this question now, we're going to be applying Hess law in solving questions under this concept. So you have to be relaxed, be calm, because if you make mistakes under this part, you may not be able to understand what I'm trying to pass across to you. So be relaxed. Exactly. It's actually very simple. It's not difficult at all. So let us start. So I'll start by erasing the board so I can create more space to explain to you. Now, the question says, calculate the standard enthalpy of formation of carbon disulfide from its elements. From here, its elements. Given that this was what you were given. You were given the formation of CO2, the delta H of it. You were given formation of SO2, the delta H of it. You were given the product CO2, SO2 when carbon disulfide is reacting with oxygen, and this was the delta H. I will give you a shortcut. Now, what is the first step? The first step is to be able to write the reaction or write the reaction for the formation of carbon disulfide from the two elements that forms it. Now, step one, you come here. For us to form carbon disulfide, of course, it should be formed from carbon, right, plus 2 sulfur. Now, please take note, meaning you are looking for the delta H of the formation of carbon disulfide. This is what you are looking at for. Now, please take note. Let me help you to underline this part. Your major target here is this. It means that you are going to be rearranging this series of steps. This is step 1, step 2, step 3. Now, when you add these 3 steps together, at the end of the day, this is what you should get. So we are going to be following it. Please take note of it. This is the first step. If you are not giving in the question, make sure you write yours out. For example, they tell you calculate this, calculate the standard heat of formation of H2O. Of course, for water to be formed, it is formed from its elements, which are hydrogen and oxygen. So you should have this concept. Now, this is the first step. We now move. Now, please take note. I will explain. Now, we start from this carbon here. We have to rearrange this series of steps here to a level that when you combine them together, you should have this final concept. Please watch till the don't skip this video. Watch till the end because you understand it at the end of the day. Now what do I do? My carbon here, where is it located? It's not in the reactant. So it means, so if my carbon here is in the reactant, it means that the step 1, which is this one, will not be changed at all. What do I mean? Meaning I come here to say carbon plus O2 to give me CO2. My delta H I was given for that one was negative 393.5. Now I continue. Now I ask myself, in the case of step 2, first of all, I move to my overall here, which is carbon disulfide formation. My sulfur here is in the reactant, and in step 2 here, my sulfur here is also in the reactant. So what do? I will still leave it like this. I'll bring it out to say sulfur plus O2 to give me what now? SO2. But be very careful. For that of the final product, that a final reaction that you are giving here, you are having 2 moles of sulfur. It means that in this step 2 here, right, because your watchword is this one that you are having here. This is your watchword. So you are trying to see how you can rearrange step 1, step 2, step 3 in such a way as at the end of it, when they cancel out, it should give me this final one. So what do? I'm having 2 moles of sulfur here. I will have to multiply everything here by what now? By 2. And whatever if you are multiplying this reaction by 2, you have to multiply the delta H also by 2. Do you get at all? Right? I know it's easy. I know it's easy. My friends around the world, from New York, from different parts of the world, listen. Now I come here, I multiply here by 2, here by 2, here by 2. So my delta H here now will now be what? 2 multiplied by negative 296.4, which should give me, as 2 multiplied by 296, which should give me negative 592. Okay? Now, this is the final step here. Now, take note. My carbon disulfide, there's an error here, okay? My carbon disulfide is in the product, right? Meaning the final reaction here is in the product, right? But my carbon disulfide here in this series of steps is in the reactant. So what do? I will have to change it. I'll have to turn it, meaning this one will come here, this one will come here. So it means that I will now be having CO2 plus SO2 to give me what now? Carbon disulfide plus what? 3O2. Now please take note. Because I move this former product here to now be in the reactant, or because I interchange it, this sign too will also interchange. Meaning, I move this product to the reactant. It is only the signs here that only changes. Meaning, if I was having negative before, it will not turn to plus because I've already do I've already interchanged it. So here becomes delta H is equal to plus 1073.6. Now, let us see whether we'll get this final product. Of course, I move here. What do I do? What do I do? Okay. So, there ought to be 2 years from the initial reaction. There ought to be 2 years from the initial reaction. So what will I do here now? So it's okay because of sulfur here is 2. So there ought to be 2 sulfur here. So CO2, we have to cancel CO2 here. You understand? SO2, which was 2 here, we have to cancel these 2 SO2 here. Now take note. 1 oxygen plus 2 oxygen, is it not 3? Which is also 3 here in the product, meaning the reactant here was 3, product here was also 3. So this 3, we cancel this one here. So if I should bring out what did not cancel out, carbon did not cancel out, plus 2 sulfur here, carbon disulfide did not also cancel out in the product. So if you observe now, here and here are what now? Equal. So what do? You just simply add this 3, which is delta H is now equal to, okay, negative 393, negative 592 plus 1073.6. The final answer is 88.6 kilojoule. So the standard enthalpy of formation of carbon disulfide now is simply 88.6. So please take your time to understand the way I have done so here. It is actually not difficult. So follow the changes I made from the initial beginning. Exactly. So I'm going to be solving the next question under this X law to actually make you understand much more better. Do well to stay tuned, subscribe, like, and share. Thank you, and God bless you.